what makes our senses different from each other? What makes a sight and not a sound? What makes a sound and not a smell? We don't have a simple answer, but there are some tools we can use, like analysis and synthesis, that can help us at least think about these questions better. Let's start with analysis first, where we break things down into simpler parts and compare the differences. For instance, take gold and mercury. Gold is a yellowish solid, and mercury is a silvery liquid at room temperature. They're clearly distinct from each other. But if we break them down far enough, we find that they're both made up of the exact same building blocks: protons, electrons, and neutrons. What makes gold gold is that it has 79 protons per atom, along with 79 electrons and 118 neutrons. What makes mercury mercury is that it has 80 protons per atom, along with 80 electrons and 121 neutrons. Now, this tells us a number of things. It tells us how similar their compositions are. They're next-door neighbors on the periodic table. It tells us what direction we need to go if we want to convert one of these elements into the other. It also tells us where other elements might be, even if we haven't discovered them yet. The existence of gold at 79 and mercury at 80 implies the possibility of platinum at 78, hydrogen at 1, uranium at 92, and others. Can our senses be analyzed in a similar way? Can we come up with a periodic table for qualia where we can point to one sense element having one more sense proton than another? We do know that different parts of the brain are involved with different senses. If your visual cortex is disrupted, you won't be able to see properly. If your auditory cortex is disrupted, you won't be able to hear properly, and so on. But the different functional areas of the brain don't seem to be that chemically different. I mean, it's not like the visual cortex is made up of platinum and the auditory cortex is made up of gold. Perhaps there are some very subtle chemical distinctions that can explain sensory differences. Or maybe we need to look at a different level of abstraction to get at differences that mean something. Researchers are looking at various ways to analyze activity at different scales to see if we can identify patterns, like with individual neurons and other cells, groups of cells, larger networks, etc. However we get there, at some point we should be able to ask the question of how do we go from one sense to another? For example, what would we have to do to an auditory cortex to transform it into a visual cortex, or an olfactory cortex for that matter? For centuries, there was the question of whether alchemy was possible with the chemical elements. Today, we know that it is possible with nuclear fission and fusion. Can we do alchemy with sensory elements? We know that it doesn't take anywhere near as much energy as fission or fusion. All it takes to construct and maintain every part of our brain is ordinary food. And there's already a blueprint for the whole process, the genome. Every cell in our brain shares a common ancestor with every other cell in our brain. As we learn how to read the blueprint better, we should be able to rewind and play back, perhaps even fast forward the process. We should be able to convert any group of cells into any other type of cells. It's fascinating to consider what we might learn along the way. What new senses might we bump into that we don't even know about now? We may well end up building a periodic table of qualia that's far more complex than the periodic table of elements. Now let's shift from analysis to synthesis, where we put things together to form a greater whole and see what that bigger picture looks like. When we consider all of our senses together, is there something that unifies them? There's the famous story of the blind men and the elephant, where each person only grasps part of the picture. I wonder if our senses of sight, sound, smell, etc. may be analogous to things like the tusk, the trunk, the foot in the story. When we see the elephant as a whole, we immediately realize where the trunk is relative to the foot. Maybe there's a qualia elephant that connects all of our senses together and makes it immediately obvious where hearing is relative to, say, smelling. This approach is harder to describe than the analytical approach because it isn't just a bunch of logical linear steps. Instead, we make intuitive leaps. It's kind of like looking at a word that has some blank spaces with missing letters. When we solve the puzzle, we get a sudden flash of insight that just gives us the whole word. We don't consciously go through every possible combination of letters. As we become more aware of how we experience our senses, our intuitions are bound to get better. Who knows what elephants we'll end up seeing? Now, just like analysis has its own limits, synthesis does too. When we analyze too much, we can lose sight of the forest for the trees. On the flip side, when we synthesize too much, we can conjure up imaginary forests on the basis of a leaf that happens to be blowing in the wind. Extrapolating beyond a certain point from the senses that we currently know about may be misleading. I think the key is to be flexible in using both the logic of analysis and the intuition of synthesis. Each can uncover assumptions made by the other. When we're willing to inquire into those assumptions, we get a better appreciation for what's going on. We can use intuition to choose promising starting points for analysis, and we can use analysis to isolate quality data points for synthesis. What do you think makes our senses different? What do you think about analysis and synthesis, or any other technique for that matter? Feel free to share your thoughts.